All right, everyone, we're back working on Project Blown 29. We're over at Larry's house today, working on his mill here and doing some custom machine work on our heads. And what we're working on here is right inside the combustion chamber here, where the valves are. We're machining out this area right in here. And basically we're taking 60 thousandths material off basically the lid of the combustion chamber of the heads here. So we made these little discs here that we can kind of set in the corner here, and then we're centering off of that, and then Larry's zeroing out his machine off of that, and then kind of has a little program going on here to be able to machine one side, then it comes up and goes over and drops back down, machines that side over there. So we kind of straighten the head in here on the bed here. We clamped it all down by zeroing in off this back side right here, so we know everything's in straight, everything's clamped down flat. We made these little standoffs here to be able to set the head down onto, and I can show you on the other head over here exactly what we did to make sure everything's true. Is we went in on the mill, we came down, we plunged off on 7 different spots on the head here, and with these standoffs we're just kind of super gluing them onto those spots and then clamping it down on his bed. So you can see on this head we're done, everything's done here. Like I said, 60 thousandths deep. It doesn't seem like a lot, but it kind of helps true the whole bottom up here and clean everything up, and then I'll use a flapper wheel to clean all this stuff up right here eventually once we're done with all the machine work. So I'm gonna let Larry kind of explain here exactly what he's got going on this mill. It's kind of a neat deal to be able to just hit start and this thing comes down, machines everything out for us. It's a pretty cool deal, and I'll kind of let him explain what he's got going on here.
All right, so what we did was Todd took the disc, we set her in there, he came over and zeroed off on a thing. After some pre-calculations of what the radiuses are, we got a program that's going to come in here on the center line. It's going to take 250 thousandths of the cutter, which is a 1/2 inch diameter carbide cutter with a radius on the corner of it, so it blends in nice when it comes around these edges here. So it eliminates a lot of messing around. It's going to plunge down, and it's going to take out initial cut from this height is our deck height, so our Z height starts at 0 here. Comes over in the center line, drops down 375 thousandths, so it takes off the first cut. It'll come back to 0. It'll go down another 25 thousandths, helically interpolate around, or circular interpolate around, and then it'll drop down a little bit for a last finish cut. So there's 3 passes that this thing takes. Goes back to the center line. Machine brings the head up, comes over here, 1 inch 780 thousandths, which is we did predetermined center line, and does the same thing over here. And then we stop it on the center line, and we bring it up and we clean up the areas that are in between the 2 holes right here and here, these 2 spots right there, because there's a little bit of a leftover material there, so we just dust it off by hand basically. We don't have that part programmed. So that's what we're up to. So here we go. We come over here and we hit run on program number 1. We get ready with all the...
And Larry, what kind of machine is this? I mean, what kind of controls are we kind of basically dealing with here?
This is an older school CNC. It's called a Miltronics Partner 4. It's pretty old school controller on it, but it's also a conversational controller on it, which is really nice. So you can stop things and move your tools around and resume your last locations and things like that. This area here that you're seeing, we did not do that. That was some old stuff from when Todd got these heads. Somebody must have dropped a BB or something in there. We don't know what that's all from, but that's not part of it.
Yeah, well, and I'll end up, polishing that out a little bit once I get my flapper wheel down in here, and I'll blend this surface in up to through here, and then over here I'll just clean the high spots off. But yeah, I think we dropped a BB in there, and it seems like it sits right in one of those holes. So however a BB ended up into the cylinder of this motor is beyond us, but I mean, it was all over the top of the piston. It's all over the bottom of the head. It was a running engine. I don't know how it ran, the way it was beat up like that, but yeah, it was kind of weird to see this in the top of the head like that.
All right, here we go. So we're going to get ready with the feed holes and all that stuff just to make sure everything goes well. Spindle's running at 1,000. We're not using any coolant or anything like that because it's just cast aluminum. We don't really need to. Start it off at a little bit above, and it brings it down, starts our cut. And make sure you keep the chips out of the way. And wrap around the cutter and start balling up on it. not running real fast. It's kind of an older end mill cutter, so it's I'm backing off a little bit on it. And you'll notice the blend on the sides is pretty nice. We just kind of did some pre-math on it down here in these corners to help eliminate a lot of hand work. Going to center, it's going to drop down another 25 thou. Take off and do it again. You could do it all in one shot, but it's a little nice to take your time on some stuff. Make sure nothing goes south on you.
Yeah, if we did it all in one cut and there was a machine error, we'd be doing damage real soon. This type of cutting that we're doing a little bit at a time, and we're able to stop the machine if it decides it wants to make a wicked move on us.
We did notice some differences from cylinder to cylinder from the depths too. We just want to make sure that we're not going overboard on anything. You'll notice that in the cuts. Some of the cuts will leave a little material here. Some will clean it up a lot better.
This disc here that we had machined up, it was 1 inch 780, and we got that measurement out of a book, basically to be able to figure out our center line. And by having that disc, we just shove it in the corner of the valve relief that's already in the head and center right off of that. It really takes a lot of the guesswork out of it pretty quickly.
This is our last cut here. It's just a little dust cut. And it's going to go back to the center line. We're staying on the Y0 when we're moving it over. We just kind of split the differences between the offsets on these. We're just going back to center now. It's going to go up. Come over here, 1 inch 780, which is the diameter of that disc. We'll come back down. Take our first cut.
What was the radius again on the edge of that end mill?
Radius is about 30 thou.
Okay.
It's just a guess. I'm not positive on that, but I'm pretty sure that's what it is.
These are an Offenhauser 400 series aluminum head that we are machining here. Really the main thing for the machining is just to take a little bit of compression out of the engine, because we are building a supercharged engine here. So we'll be adding compression in with the supercharger. So we were just trying to get our compression, our initial compression down a little bit more in the 8-to-1 range. Instead of with these heads, you're a little bit up over 9-to-1 on your compression ratio. So we're just trying to drop that compression down a little bit. Larry keeps his finger on that feed hold button just in case the machine decides to do something wicked on him. And
she's an old girl. You know how they are.
Yep, she might go dumb all of a sudden. And I have seen the same process done on a Bridgeport, a manual mill with the right size diameter end mill, but that size diameter end mill is really hard to find, and all you have to do is just do a plunge cut with it then. But when you can get into a CNC mill like this, it doesn't matter on your end mill size. You can just program it to do a radius of whatever size you want.
It gives you more freedom to do what you want.
So we're on the final cut here, and once it comes around, and then we'll hit a feed hold, and then we're gonna just manually dust these other spots. But you know, I'm gonna stop it before then. We're just gonna kind of explain what we did on everything. But that's basically the gist of what we did here, is on how to machine this head out. Not everybody has a machine like this sitting in the corner of their garage.
But they should.
Yeah, exactly. It's definitely a glorified drill press.
Going back to center now.
Yeah.
We're gonna hit feed hold right there.
So this is where we pretty much stop the machine, and then we just kind of eyeball the machine up these last couple little bits that we don't have programmed into the machine.
Right
so
here.
Yeah. So
Right here.
So yeah, we'll just dust across those by hand. But so yeah, that's how to machine your heads for a supercharged flathead, guys. And thanks for watching. Please subscribe, comment,